All right, welcome to screencast number 3 for Unit 5, Lesson 2. And I'm on page 240, 241, and we're going to talk about eclipses. All right. An eclipse is an event during which one object in space casts a shadow onto another. On Earth, a lunar eclipse occurs when the moon moves through Earth's shadow. There are two parts of the Earth's shadow, as you can see in the diagram below. The umbra is the darkest part of the shadow. Around it is a spreading cone of lighter shadow called the penumbra. Just before a lunar eclipse, sunlight streaming past Earth produces a full moon. Then the moon moves into Earth's penumbra and becomes slightly less bright. As the moon moves into the umbra, Earth's dark shadow seems to creep across and cover the moon. The entire moon can be in darkness because the moon is small enough to fit entirely within Earth's umbra. After an hour or more, the moon moves slowly back into the sunlight that is streaming past Earth. A total lunar eclipse occurs when the moon passes completely into Earth's umbra, Earth's darker shadow. If the moon misses part or all of the umbra, part of the moon stays light and the eclipse is called a partial lunar eclipse. You may be wondering why you don't see solar and lunar eclipses every month. The reason is that the moon's orbit around the Earth is tilted by about 5 degrees relative to the orbit of the Earth around the sun. And this 5 degrees is enough to place the moon out of the Earth's shadow for most full moons and is enough to place the Earth out of the moon's shadow for most of the new moons. Okay? The big thing that you need to understand about a lunar eclipse is the neat thing that's happening is happening with the moon. Okay, that's why we are going to call it a lunar eclipse. A lunar eclipse happens at night, and it happens during the full moon. It has to be a full moon, and that occurs only if the full moon passes through the Earth's shadow. So everything has to be lined up perfectly in a straight line for us to have a lunar eclipse. And remember, most of the time everything isn't lined up quite right because we do have that tilt of the moon's orbit around the Earth by about 5 degrees. So most of the time the shadows miss the objects that they would normally be eclipsing. All right, how do solar eclipses occur? When the moon is directly between the sun and the Earth, the shadow of the moon falls on a part of Earth and causes a solar eclipse. During a total solar eclipse, the sun's light is completely blocked out by the moon, as seen in that photo. That photo on the page is actually like a time lapse. There's actually 5 different photos all put together. So the middle one shows you where the moon is completely blocking out the sun, and the only thing that you can actually see of the sun is that outer corona. Okay, the other ones, it looks like a piece of Cookie Monster taking a cookie bite or whatever out of the sun. Those had to be taken through a filter, and the only one that you can take without a filter on is that total eclipse in the middle. Okay, the umbra falls on the area of Earth that lies directly in line with the moon and the sun. Outside the umbra, but within the penumbra, remember that lighter shadow, people can see a partial solar eclipse. So if you guys were around last fall and you came by, it was a football day, and you saw the moon taking kind of a cookie bite out of the sun, and you had to look at it through a filter that we provided for you, that was a partial solar eclipse. Okay? So the penumbra falls on the area that immediately surrounds the umbra. The umbra of the moon is too small to make a large shadow on the Earth's surface. The part of the umbra that hits Earth during an eclipse is never more than only a few hundred kilometers across. So a total eclipse of the sun covers only a small part of Earth and is seen only by people in particular parts of Earth along a narrow path. A total solar eclipse usually lasts between only 1 to 2 minutes at any one location. A total eclipse will not be visible in the United States until 2017, even though there is a total eclipse somewhere on Earth about every 1 to 2 years. Okay, so The neat thing about solar eclipses, again, we call it a solar eclipse because something neato is happening to the sun as we see it. A solar eclipse has to occur during a new moon, and it occurs when the moon, from our perspective, seems to block out the sun. Solar eclipses, new moon, and has to happen during the day because the sun has to be up, duh. Okay, lunar eclipses happen during full moons only, and they have to happen at night. Okay. All right. We do have the diagrams for the bottom for a lunar eclipse and a solar eclipse, but I want to take a moment and look at another diagram. This diagram is actually not in y'all's book, but it was taken from another textbook, and I think it's an excellent explanation as to why we don't have eclipses every month. Okay. So remember we said that the orbit of the moon around the Earth is tilted by about 5 degrees relative to the Earth's orbit around the sun, and that's what this is showing. This red circle is the Earth's orbit around the sun, and the blue circle shows you the moon's orbit around the Earth. And you'll notice with the little grid that they gave you, they're trying to make it so that you understand that it's tilted. So most of the time things don't line up. Okay. For instance, here, if the moon is in this position, we're having a new moon, but things aren't lined up perfectly enough for the moon's shadow to be hitting the Earth. So it's just a regular old new moon. Same thing here. This would be an instance of the full moon. But again, the Earth's shadow is not covering the moon because the moon's orbit is tilted a little bit and we can't get everything lined up perfectly. Okay? Every once in a while, things do line up. So for instance, here, we would have, this is depicted, what would happen if everything lined up. If the moon was right here, we would be having a solar eclipse. If the moon was right here, we would be having a lunar eclipse. Okay? Here, we don't have a solar or a lunar eclipse because not everything's lined up perfectly. The shadows miss each other. Okay? So solar eclipses can only occur during a new moon when the Earth and the Sun are on opposite sides of the moon. However, solar eclipses do not occur during every new moon phase because the moon's orbit is tilted slightly compared to the Earth's orbit. As a result, during most new moons, Earth is either above or below the moon's shadow. However, every so often the moon is in line between the sun and the Earth, and then the moon's shadow passes over the Earth and a solar eclipse occurs. Okay? All right, I am actually on my website because I want to show you guys that there are some videos that would be very helpful that are available to you guys about eclipses. Okay, so I've scrolled all the way to the bottom. There's this one, The Sun Explained, talking about an annular eclipse. An annular eclipse is a type of solar eclipse, but the moon is a little bit too far away in its path, and we don't get the moon appearing quite big enough to completely cover the disk of the sun, so you get a ring. Annulus means ring. And I actually went and saw this one in May 2012, and I have some pictures that I'll share with you guys when I get a chance. It is a type of solar eclipse, but like I said, the moon's just a little bit too far away from the Earth to appear large enough to completely block out the sun. So this one would be interesting to look at. You have a small area where you would see the annular eclipse, and then you have a much larger area where you'd be able to see a partial eclipse where part of the moon is blocking out the sun. Okay. There's another one up here, midnight eclipse. This is actually a solar eclipse. I don't think it's it's not a total solar eclipse. But anyway, this is a really neat one because this is actually at a very, very, very high northern latitude, high enough that the sun does not set. It simply moves around the horizon, and so you see the eclipse just drifting along the horizon rather than the sun rising or setting. Okay. This one is complete with creepy music. This is a lunar eclipse in time lapse, so it shows you the entire eclipse sped up so that it only takes you a couple minutes to watch it. But I would encourage you guys to go and look at all of those videos. Okay? Okay, so now I'm back on 240 and 241, and I've marked everything up. You guys can probably see where I've highlighted. I've highlighted the definition for eclipse. I forgot to underline umbra and penumbra. Okay, but it's mentioned down below also. Okay, so eclipse, umbra is the darkest, smaller inner part of a shadow. Penumbra is the broader, lighter part of a shadow, the outer part. Okay. If we're talking about a lunar eclipse, the entire moon can be in darkness on a lunar eclipse because the moon is small enough to fit entirely within the Earth's umbra, and that's diagrammed down there on number 11. Because remember, the Earth is much bigger, the moon is smaller, so the Earth is going to create a bigger, longer umbra than the moon, and so the moon is capable of passing completely into the umbra of the moon. Of the Earth. Really, really, really important. You may be wondering why you don't see solar and lunar eclipses every month. The reason is that the moon's orbit around Earth is tilted by about 5 degrees relative to the orbit of Earth around the sun. This tilt is enough to place the moon out of the Earth's shadow for most full moons and the Earth out of the moon's shadow for most new moons. So most of the time we don't have eclipses, but every once in a while things line up just right. Okay? Over here, in regards to lunar eclipses, at the top, I reminded you that a lunar eclipse will occur at night and has to occur during a full moon. Okay? Down here, I reminded you that for a total lunar eclipse, the moon is going to have to pass into the umbra of the Earth, the central dark portion of the Earth's shadow. For a partial lunar eclipse, the moon is going to pass through the penumbra. Okay. Okay, looking at solar eclipses. How do solar eclipses occur? When the moon is directly between the sun and the Earth, the shadow of the moon falls on part of Earth and causes a solar eclipse. During a total solar eclipse, I put a little arrow, the umbra falls on the area of Earth that lies directly in line with the moon and the sun. Outside the umbra, but within the penumbra, people will see a partial solar eclipse. Okay? Now, for a solar eclipse, you're having the much smaller moon cast a shadow on the much bigger Earth. So the dark central umbra, the central portion of that shadow, is going to be very small. Okay? The umbra of the moon is too small to make a large shadow on the Earth's surface. So, a total eclipse of the sun covers only a small part of Earth and is seen only by people in particular parts of Earth along a narrow path. Okay? Outside of the umbra, the larger, lighter shadow area called the penumbra, people in that area would see a partial solar eclipse. Okay? So if you were looking at a partial solar eclipse, you would see something like this. Okay? All right, again, a solar eclipse, to remind you, I put this up at the top. Solar eclipses occur during the day, and they have to occur during a new moon. Okay? We actually have 3 types of solar eclipses. We have a total solar eclipse, where the umbra falls on part of the Earth, and you have to be in a pretty specific point to see a total solar eclipse. You have partial solar eclipses, where people are within that penumbra area. And then you have a third kind known as an annular eclipse, which your book does not discuss. An annular eclipse is you would be in the umbra, except the moon is too far away. The moon is too far away because y'all know when something's further away, it appears smaller. And the moon is too far away for it to be big enough to completely cover the entire disk of the sun. So you wind up with a ring when it moves directly in front of the sun. You wind up with a ring or an annulus. That's why it's called an annular eclipse.